Now that you've seen a basic overview of how Scratch works and had a chance to explore, you'll be introduced to the different block types that Scratch uses. There are 7 different types of blocks in Scratch, and each has its own shape. Statements tell the computer to do something. That can be move 10 steps, play sound meow, or wait 1 second. Loops tell the computer to repeat doing something. Loops have a U shape and expand to fit other blocks. Types of loops include forever, which repeat for the entire program, or repeat 10, which allow you to select how many times you want the program to repeat. Events tell the computer when to run code. You'll notice that they have this rounded shape at the top to show that they cannot have anything connected above them. Events include when green flag clicked, which acts like a play button for most programs, and broadcast, which allows you to tell another part of the program that it's time to run code. Booleans take this prism shape and tell the computer whether something is true or false. This could be, is the sprite touching the color black? Is the value of the score less than 1? Or simply, is the mouse pointer touching something? All questions that have a true or false answer. These blocks are used with the next logic type, conditions. Conditions have 2 parts, an if and a then. They read, if this is true, then do this. You can see how the Boolean block fits into the top right here. Variables store a value and take this round shape. Scratch has some variables already created, like timer, which stores the time the program has been running, and X position, which stores the X position of where the sprite is located. But you can also create your own in the data category. Finally, there are functions, or what could also be called a procedure or method. Functions are located in the Make a Block section and allow you to combine complex code into one block. To demonstrate how some of these pieces work together, let's make a quick moon jump program. This is a new Scratch project. Remember that you can get here by going to scratch.mit.edu and clicking Create. As you may recall, the motion category contains statements. The Move 10 Steps block moves the sprite forward, but for a moon jump, the sprite is going to need to move up and down and left and right. The Scratch stage contains an invisible coordinate plane, meaning that each position on the stage has an X and Y value. The X values are left and right, and Y up and down. So the Change Y by block moves the sprite up. Connecting these blocks won't appear to do anything. The computer runs them quickly, and the end result is a sprite being in the same spot. So another statement, a wait block, in between these two can ensure that you can see them run. This sprite now moves up and down using these sequence statements. I can make these movements look more like a moon jump using loops to repeat many small movements. I won't need the wait now either. I can further use loops to repeat this jumping movement many times. And by adding a green flag event, this program now uses loops and statements to create a moon jumping cat. But what if I wanted to move the cat left and right while it was jumping? I could put change X blocks, which move the cat left and right into this loop, but then the cat would move diagonally. Scratch allows programming in parallel, meaning I can create 2 block stacks that run at the same time. The easiest solution to this problem is to make a new block stack that moves the sprite left and right. Now there are 2 block stacks, one to move the sprite up and down, and one to move left and right. But let's say we wanted to incorporate a flip into this routine. I could use another loop with a turn block to create a flip. I could even create a new block, call it flip, to create my own procedure. But where to put this flip block? I could put it here after the sprite has moved up, but let's try something a little more interesting. Let's start a new block stack and use a forever loop with an if block. If blocks are a type of conditional. We'll make the same. If the sprite is above a certain point on the screen, then do flips. To do this, I'll need an operator. There are a few prism-shaped Boolean operators, but for this, I'll use a greater than operator. I can then click on motion and scroll to the bottom to find a Y position variable. As I mentioned earlier, there are a lot of variables already created in Scratch. This one stores the Y position on the screen. We'll say if the sprite is above -20, which is a little below the halfway point, then flip. I'll add the flip procedure and try it out. Okay, great. Let's recap what's happening in this program. First, this block stack contains loops and statements. The change Y statements move the sprite up and down, and the loops repeat those movements for the entire program. This block stack uses the same type logic to move the sprite left and right. This block stack contains a loop, a conditional, a Boolean, a variable, and calls a procedure. It tells the sprite to flip if it's above a certain point on the screen. Much of the power of computer science is in the ability to abstract, meaning that you're able to take something incredibly complex like telling the computer to simultaneously move the sprite up, left, down, right, and check if the sprite is above a point, then rotate 30 degrees 12 times. We're able to do all of that with a few lines of code. This video included a description and demonstration of the many block types in Scratch. I understand that it can be a little overwhelming. After spending a little time in Scratch, these concepts will become much more familiar. The best way to prepare for each club is to ensure that you're watching the videos and completing the projects before each club day.